In this video, we will vary the wavelength of sine Wx using W as the factor. So data validation, list of items, 0.66 to 1.5. So 0.66 to 1.5. We can start with 1. Likewise for G, it is data validation, list of items, again 0.66 to 1. G is equal to W. In this case, we'll show the distinction between the two. So we start with the dataset of sine x, array formula, sine of the x, Wx. So W times x. That's sine W times x. And the Maclaurin series expansion, which is the summation of a times x to the power 2n plus 1, where the value of n is from 0 to infinity. 17 is good enough. And the value of a is array formula minus 1 raised to the power n. That's the first part of the numerator. Times the second part, g, that's g raised to the power the quantity 2n plus 1. So g raised to the power the quantity 2 times n plus 1. We have just completed the numerator. Now we continue with the denominator. This is divided by, this is factorial 2n plus 1. So factorial 2 times n plus 1. So this is, so we can start at 1. Now we can complete the Maclaurin series expansion. Array formula, series sum of the x values raised to the power, that's raised to the power, comma, raised to the power 2n plus 1. 2n plus 1 starts from 1, incremented by 2. And the coefficient will be a, this range, the a range. And we'll chart this. Insert chart. And we use scatter chart. Column S label. We delete the title, we don't need that. We need a space. We show the trend line. The type of the trend line, polynomial. The degree, 8. For the label, use the equation. For the legend, position at the bottom. So here's our trend line and polynomial of the sine Wx and its Maclaurin series expansion. We'll calculate this polynomial regression coefficient using Linus. To do that, we complete the Linus matrix, which is equal to transpose 0 to 8. And the elements of the matrix are a formula of the x values raised to the power 0 to 8. Now we can use Linus. Linus data y, that's for the sine Wx, comma, data x. For the expansion, Maclaurin series expansion, Linus data y and data x. And let's compare the polynomial regression coefficient. This is coefficient of x to the 0. This is 0 times 10 to the minus 29, that's 0. Coefficient of x, 1.07x. Coefficient of x squared, 0.194, negative 0.194. Coefficient of x cubed, 0.0433. Coefficient of x to the fourth, 0.119, negative 0.119. Coefficient of x to the fifth, 0.074. Coefficient of x to the seventh, negative 7.38 times 10 to the minus 3. Coefficient of x to the 7, 5.14 times 10 to the minus 4. Coefficient of x to the 8, 1.34 times 10 to the minus 5. Suppose I change this to 0.6. So this is now, the wavelength is now longer. I want this to also to increase the wavelength a bit. 0.8. Now it's getting closer. Now I change it to 0.6. Now they are the same. Suppose I change this to 1.5. That's the wavelength is shorter, meaning the frequency is high. So I want this to change to 0.8, 1, 1.25, and 1.5. Now they're the same. This completes the use of Taylor-Maclaurin series sum and Linus polynomial regression to generate the varying wavelength of the sine function using the factor W.